Welcome to Spring LIB.
So in this question, we have two capacitors. One is 0.5 microfarad. One is 0.8 microfarad. They are connected in series to a 9-volt battery. And we want to find the potential difference across each capacitor. So that is V1 and V2. If I call this capacitance 1 and this is capacitor 2. And part 2 asks us the charge on each, that is Q1 and Q2. Part C asks us to do the same, except that assuming these two things are in parallel instead of in series. So let's look at part A. In part A, because the two capacitors are in series, the charge on them will be the same because they're connected by a wire, and because if you look at the middle part, this part is isolated, so whatever negative charge it has on the left side, it must have the equal and opposite charge on the right side because this part is isolated and because the charge cannot get into and get away from this part. So if it was neutral before the whole thing is connected to the battery, it must overall remain neutral afterwards. So that is why the charge on the two parts has to be equal. And anyway, so we have this Q1 equals Q2 equals Q equivalent. So that is the definition. That is what happens for capacitors in series. And the definition of Q equals C times V. And again, for capacitors in series, C equivalent equals 1 over C1 plus 1 over C2 times V. So now we can find the values. This tells us 1 over 0.5 times 10 to the negative 6 farad plus 1 over 0.8 times 10 to the negative 6 farad. And again, times the voltage is 9 volt. And this gives us 2.769 times 10 to the negative 6 coulomb. So that actually already answers part B. Q1 equals Q2 around 2.8 times 2.8 microcoulomb. And we still need to find the voltage. We actually ended up doing part B before part A. When we find voltage, because voltage V equals Q over C. And for the two capacitors, they have the same charge as which we just found, but they have different capacitance, so they will have different voltage. So V1 equals Q1 over C1, which is 2.769 times 10 to the negative 6 coulomb over C1 is 0.5 times 10 to the negative 6 farad. And this gives us 5.5 volt. And V2 equals Q2 over C2 coulomb over 0.8 times 10 to the negative 6 farad, which is 3.5 volt. So that is the first two parts, when these are in series. When these are in parallel, so it's easy to find the voltage because when things are in parallel, they just share the voltage of the battery. V1 will be equal to V2 equals 9.0 volts. And then we can find Q with the same way that Q equals C1 V1 equals 0.50 times 10 to the negative 6 farad times 9.0 volt, just 4.5 times 10 to the negative 6 coulomb. Q2 equals C2 V2 equals 0.80 times 10 to the negative 6 farad times 9, which is 7.2 times 10 to the negative 6 coulomb.